All right. Good morning, everybody. Welcome back to Comp 2452. I hope you're all having a good day today, staying warm. The forecast for next week is looking like it will be warmer. It will be warmer, but it will be February in Winnipeg, so it's still going to be cold, but it won't be like 20 below every day. That said, I don't know. I don't really trust forecasts. They're often wrong. They're often quite wrong. It might be 30 below every day next week. I've got no idea. So in Cookie Clicker, all right, we are just plain lucky here. You have a one chance in 1 million every second of earning this achievement. We did it. Congratulations, everybody. We worked really hard to. Yeah. Let's buy some upgrades here. We're making 7.3 billion cookies per second now. And I'm not going to go through the mini games here other than I think to summon some cookies. We summoned some cookies here. I'll buy a bunch of buildings. We're starting to get to like the hundreds of things and hundreds and fifties of things. And so we're starting to get these upgrades for the different buildings that we've got. So like these are going to make different buildings more efficient than they were before. I'm going to save this research path for A02, but at this point, I'm guessing I'm not going to have a quadrillion cookies by this afternoon, so it'll have to be next week that we're doing that for A02. Don't you love that we all get to play Cookie Clicker in class now? Yeah, I don't know. I love it. All right. So today we are going to kind of switch topics entirely. In the last three or four classes, we've been focusing a lot on doing implementation related stuff with TypeScript and Vite. We've been doing like testing stuff with vtest. We've been thinking about this idea of frameworks. We've been building up this fairly minimal model view controller implementation. So we're applying this architecture to a small problem. At this point, we're going to switch to starting to think about persistence. As it is right now, for the projects that you're working on and for the simple thing that we've got with the model view controller, when I hit the refresh button on my page, we're just starting from scratch again. And this is the same problem that we had last term in Comp 2450 with our software. When we hit the stop button and we hit the start button, we're just starting all from scratch again. And so what we want to start thinking about here is how do I take the domain model objects that I've got and set those up so that I can persist them across refreshes of this page. Every time I refresh the page, I want to have some state that's been kept as a result of that. In Comp 2450, we used JSON for persistence. This was a structured file format, and we were just dumping objects into that structured file format. And we didn't really think too much about it. Like we had to work with these kind of painful JSON builders, but it was just dumb and tedious code. It was a one-to-one relationship between our domain model object and this JSON object. We didn't have to think about how that structure looks. We just called accessors and mutators and builders, and we went down to JSON, and we came back from JSON back to our objects. In this course, we're going to think about relational databases. And relational databases, to kind of give you a small preview of what we're going to do today, relational databases are not object-based. They're not class-based. They are table-based. And what this means is that we're going to be taking our domain model objects, or classes, and we're going to have to be translating those into a two-dimensional format, basically. I want to represent these things as tables. I want to represent these things as tables, and that's going to mean that we're going to have to structure things a little bit differently than what we were doing with JSON and what we were doing with our domain models themselves. So what I want you to be able to do by the end of today's lecture is we're going to start this. I want you to be able to model relationships between data model objects and a database. For this, what we're going to be focusing on is we have this domain model class diagram. I want to take this domain model class diagram and add some extra information to it. I want to make some changes to it. And what I want to do with that is start to represent things like this idea of uniqueness, this idea of relationship constraints, this idea of a little bit of extra information that we need to have in the context of a database, of an actual database. Transactions is something that we may talk about later in this course, but for now you can assume that the word transactions is stricken from this. We're not going to think about transactions right now in the course. The other thing that I want to do, and this is kind of a time permitting thing, is I want to be able to start actually like working with the database today. The context here is that we're not going to be writing JavaScript or TypeScript code that's interacting with a database. That's not what I want to do today at all. The goal for today is really, I want to start working with the database, and that actually means that we're going to have to start learning a new programming language called SQL. We're going to have to start thinking about this new language that's called SQL to be able to create these tables and then maybe add data and get information about it. The three keywords that we're going to learn today, if we get to this point, are create table, insert. So I want to add things to the database, and select. I want to get things back from the database. This is a time permitting thing. This is something that we'll definitely keep going with next Tuesday in class. But the focus, again, is not getting TypeScript code working with our databases. It's just working with the database by itself. So I don't want to do any kind of web-based interaction with databases yet. Before we get to any of that, in about a week, in exactly a week from right now, we will be having a term test in this class. So I want to tell you a little bit about it, and I want to give you a chance to ask some questions about this or about anything in the course that's going on so far. So the term test is going to take place in this classroom. Please, in this classroom for those who are registered in this section of the course. For those who are registered in the other section of the course, it will be in a different classroom at a different time, but it will take place in class for you, assuming that you are registered in this class. It will take the entire time. I really don't want to like lecture at you after or before you do a test. That would be awful for everybody involved. So I'm just going to take the whole time for the class. It's allocated, the entire time is for this. When I'm preparing this test, I'm not planning to make it like you have to sit here until the bitter end with a cramp in your hand writing stuff. I'm just saying there's nothing happening after this, after the test. So if you finish, like you can leave. We're done for the day after that. The coverage is going to be up to and including lecture 9. So that's going to be next Tuesday. Please keep in mind that when I say up to and including lecture 9, the material that I would put on a test, that's the class that happens before the test, is going to be pretty minimal. Like, that's not really nice of me or fair of me to assume that you have like fully ingested what we've done 48 hours before the test. It will be small, but I want you to know that it will include up to that point in the course material. The seating will be assigned as it was for the final exam last year. So please make sure you're actually attending the section that you're registered for. As with the final exam, if you are writing this term test in an alternate location, your test will be provided to you. So you don't have you will be provided with the test that has been assigned to you. I'm planning to send the emails out for this the morning of Thursday. That's when you should expect to get that email. And then just in terms of room layout, I will try to make a map for you, but the assumption should be that seat 1 is in the first row, and then seat whatever will be closer to the back of the room. There will be some programming on this test. But there's no strict syntax concerns here. I really don't want you to memorize HTML. I really, really do not want you to memorize anything about HTML for this test. You can assume that your view is console.log. I really don't want you to memorize any HTML for this test. I don't care about HTML. Please do not memorize any HTML-related stuff for this test. TypeScript is a means to an end. When I say that, what I mean is not don't memorize HTML, but like I don't actually really care too much about things like exclamation point and question mark. When we've been talking about this in class, I've been pretty hand-wavy about this. Like exclamation point, just trust that this is not null. If you forget to put that on a statement in your code, I don't really care. I really don't care. Comp 1020 is the right place for testing syntax. At this point, I trust that you know how to work with your compiler and then fix the problem that you've got. I don't want you to have to worry about compiling code on this test. There will be no questions about cookie clicker. Please don't memorize any HTML. I really want to emphasize this. Like, don't worry about HTML stuff. There won't even be a bonus question about cookie clicker. There will be a bonus question, but not about cookie clicker. I'm going to hold this up for a few seconds, but I do want to give you a chance to ask any questions that you've got about this, the project, the course, or anything in general. I'm also very happy to answer verbal questions if you have any verbal questions. Yeah.
So does the minimum viable product imply that the design of the web page should be removed garbage, or we can do some stuff with CSS?
Okay, so that's a fair question. I like that you're using the words that I've used at you. Does the design minimum viable product mean that the design of the web page can be garbage? Does it have to be garbage? Maybe that was your question. Does it have to be garbage? No, your design does not have to be garbage. The point of what I'm trying to make is I'm not expecting you to do CSS. And in no way am I assessing you on CSS. If you want to do CSS, I very much welcome you to do that. But don't let it get in the way of doing a minimum viable product, and don't let it get in the way of other stuff. If it looks like garbage, that's totally fine. If it looks okay, cool. I'm really happy for you, but I'm not giving extra credit for it, but I'm also not taking points away if it looks like garbage. Okay. All right. Will we get sample questions before the test? So I think that I'm going to, gosh, I don't have any sample questions, but this is a fair question to ask. What I say to my children a lot is I'm not saying yes, but I'm not saying no. And right now I'm not saying yes, but I'm not saying no. This has kind of got to be a time permitting thing for me. If I have time to make sample questions for you, I will. If I don't have time to make sample questions, I can't. So I'm not saying yes, but I'm not saying no to this question. It's a good question, but I'm not going to say yes, but I'm not going to say no. Can I give you an example of a coding question to expect? That's also a fair question. So I will give you verbally an example of a coding question that I might expect you to do. In this course, so far, we've been focusing on the MVC architecture. In terms of a coding question, it might be reasonable for me to ask you to do some kind of minimal MVC related thing. So building some part of this MVC structure, or building some minimal example of an MVC architecture structure. It took us 3 classes to go through an MVC thing. And if I were to open up that project that we've been working on, that's not something that's achievable in 75 minutes, especially by hand. That's not the scale or scope of what I would be looking for here, but having something smaller that represents MVC as an architecture might be something that you can expect to see. I'm not looking to trick you with TypeScript stuff. That's not the goal of coding questions here. It's really about making sure that you have a sense of what the structure and architecture is going to look like, as opposed to having really tricky kinds of questions here. So I hope that gives you an idea of what I mean by a programming question. Would working on the project be good practice for the term test? Yeah, I think it would be good practice for the term test. Again, keeping in mind, I'm not going to ask you strict syntax questions. I don't care about HTML in the context of that. It's more about the overall structure and organization of what you're doing for the project. Gosh, I don't know. Like, what if you only memorized HTML? And I'm going to interpret this to mean that you will like force yourself to forget literally everything else that you know to do this. Then maybe you'll be close to what a web browser is. I think that's the outcome of that. I thought this was done. I thought this was over. So my partner is a middle school teacher, and my children are in elementary school, and this like went down to elementary schools very fast compared to what a lot of other things take to get down to elementary schools. If I were to ask my kids this question, even like late last year, they knew what it was. They knew the motion, and they knew like the way that you say it, but they didn't know what it was. And so I thought we were done with this already. Should the listener class be part of the domain model? So yes, I would say that the interface, and when I demonstrated this in class, I kind of made this as an interface. I believe that this belongs in your domain model, but not in your class diagram. I believe it belongs in your domain model, like in the context that that's the folder that it belongs in your code. I believe that it belongs there because it's really the responsibility of the domain model classes to say that they are going to notify things that are interested in listening for those changes. This doesn't belong in your class diagram, though. You might put it there, but for me, I'm assuming that because we are using MVC that you have a listener somewhere. I'm further assuming that you have listeners on almost all of your domain model objects where it's appropriate. And so adding that listeners field to everything is just going to clutter your diagram for no good reason. So I believe that listeners should be in the domain model. It should be in that folder for your structure, your class structure. But I don't think that you need for any of this to show up in your class diagram. I'm not sure what the question is here. Are there new comp courses?
I just got an email.
20 minutes ago.
3,000
I don't know how.
They didn't send me that email. What I don't know what you got, so I can't really say anything about what you got. But now everybody's checking their phone real rapidly to find out what they got. Yeah. Okay, so part of the changes to the third year was about the prerequisite structure for the course you're in right now to make sure that like the prerequisites have been changed. I'm gonna have to like hold this question because I need to know more about what you have seen before I could say anything about it. I'm also not I'm not really in the administration of the department. I'm not an associate head and I'm not the department head, so I don't really have a clear sense of everything that's going on that way. But yeah, I'm meeting with David Gerhard after this class today, but not about this. But I'll ask him about it. I'll talk to him about it, and if I can bring anything to you next week, I'll talk about it. Okay, so I mean the topics. I haven't written the test yet, so I can't share the test with you. The topics, I guess what I'm going to point at is, I'm going to point at this. At the beginning of each lecture in my classes, I give you these learning outcomes. When I am writing my test questions, I'm always looking at these learning outcomes. I'm trying to make sure that the things I'm asking you to do for me on a test or on an assignment align with the things I'm showing you here in class, the things that I'm kind of saying that by the end of today's lecture, you should be able to do this. In the project stuff, the rubrics that I've got at the bottom of each part of the project have these learning outcomes in them. And it kind of says like, this is how I'm going to assess you on these learning outcomes. When I'm writing the test, you can expect to see these learning outcomes showing up at the bottom of the page or at the bottom of the question for each of the questions that I've got here, because it's me trying to make sure that I'm aligning the questions that I'm asking you with the learning outcomes that I've tried to demonstrate to you in class and that I'm expecting you to be able to do by the end of each class. So to that end, the topics that should show up here are the learning outcomes that you've seen at the beginning of these lectures each time that we go through one of these lectures. The example code question, as I said before, in terms of coding, the really big focus for us has been on MVC as an architecture, as opposed to like minutia about TypeScript. There's lots of TypeScript stuff that's in the background, but ultimately the big thing that we're thinking about is the idea of this architecture. The average, so that the pass on to tests is going to be the average of the total tests. Is this a joke? I don't know. Okay, question mark? Yeah, okay. You can assume that your view is console.log. The only time we've ever used documents so far is to get access to elements on an HTML page. You can assume that your view is console.log. That's how I'm going to answer this question. Yes, this is something that you can be retested on. It will be minimal. Like you've already been tested on it like once as a quiz, once as a final exam, repeatedly on projects. We're beating this to death. There are stuff that we have changed about this, and especially as we proceed into what we're doing today, our domain models are going to change. The structure of these domain models is going to change. So we'll think about that more when we get to it, but I'm going to come back to this, and I'm going to point at this, and I'm going to say, one of the things that I'm expecting you to be able to do by the end of today's class is model relationships between data model objects in a database. And part of that will be taking our class diagrams and changing them a little bit so that they have extra information about stuff that we're going to have for the purposes of putting this in a database. So in that context, yeah, I guess you will be having some kind of assessment on domain modeling, but the purpose of the assessment on domain modeling will very much be about like the stuff that we're thinking about today more than anything else. I'm gonna give 2 more questions, I think, two more minutes for questions. If I haven't been able to answer the question that you've got, I will politely ask you to post it on the forum. But I'll prefer verbal questions first. Yeah.
So I didn't understand what you mean by like console.log is your view. Is it well,
That's a fair question. So what I mean by that is if I go to this class here, the trainer view, what I mean to say is notify here would do console.log to say that I'm going to update my view right now, as opposed to like dynamically changing the contents of a page. That's what I mean by that. So having something that looks like this, create elements, putting inner HTML, making these list items and stuff, that's not something I care about. But spitting out, this has been updated, console.log updated, here's the property. That's the kind of idea that I'm thinking about here with console.log being the output. I've actually seen other people reporting this issue that VS Code is showing errors, but NPX is still working. I guess I don't know what the error is. I haven't actually seen it. Nobody's brought their laptop to show me what the error is, but as far as I know, it's not a problem. I'm not really sure why VS Code is showing errors, but you'll have to come to show me either after class or during my office hours. Yeah, the format you can expect to be structured approximately the same way as 2450. You can expect them to kind of be similar in scope, but like I said, there will be programming questions as opposed to non-programming questions. We just have more time in a term test to be able to do stuff like that.
So I posted this question in the discussion forum. Like, what I meant by the question that when we have the view of the dialog being shown up by the controller, so the controller orders it to like instantiate itself and add that part of HTML to the page. But then it's the view that decides that I have to go away now. Shouldn't it be the controller that says, okay, this is the time for the view to go away? And then it not only says the view to remove that HTML, but also says that the property that it holds for that view, for that create bottom view, is now null. Because like before that, we were just saying the view itself decides I have to go away, but that property stays like defined there. It's not undefined, it's the object that is still in memory.
So in this case here, this is where we're making this assumption that the dialog is responsible for this view is responsible for removing itself. Your question, I want to make sure I understand what your question is. Should it be the responsibility of the controller, kind of where I've got console.log here, to tell that view to remove itself? Is that what your question is?
And also like setting the actual property that we have in our custom undefined here? Because we create it when it's needed, and then when it is not needed, should we say it's undefined now?
So it would be reasonable for us to then say create Pokemon view is equal to undefined or null here, yes. It would then also be something that we want to maybe check to see if this has been set or not set to make decisions about that, because that button doesn't disappear. And if I'm remembering our view correctly, we could click the button a bunch of times and have the modal show up a bunch of times underneath it. So yeah, there should be some logic here that's keeping track of, has this been initialized, and then removing it where it's appropriate, or not initializing it if it has already. For this create Pokemon view, the pattern that I'd expect that we probably should be using for this is something like a singleton. I want to make sure that this is only initialized once, but like not necessarily a global singleton forever. Just I want to make sure that there's only one right now on the page. Yeah. All right. So, like I said, if I haven't been able to answer your question here, please ask it on the course discussion forum. And I'll be able to answer it there. As always, I want to make sure that everybody has access to the same material or same information about the term test, just in terms of fairness. All right. Okay. So please don't memorize HTML. Let's start switching gears here entirely. In Comp 2450, our job with persistence was to take the instances of the classes that we had and transform those instances of classes into JSON. JSON is JavaScript object notation. It is JavaScript. And as you come out of Comp 2450, you should have this idea now of, Comp 2400, you should have this idea of curly braces that have properties and values, keys and values, and they can be nested within each other. And that is JSON. That's what we're doing when we're persisting these Java classes to JSON files. In this course, we're going to switch this now to starting to think about a different kind of location or format to put our persistence into. And this is going to take us into this idea of data modeling. What we have done in this course and what we did in Comp 2450 was domain modeling. And domain modeling here is where ultimately what we're trying to represent is some abstraction of the system that we're working with. The abstraction of the system that we're working with consisted of things like the nouns, the things that are in our system, the attributes that those nouns have. Typically, this has a relationship with things, like I've got this property that I need to model about this thing. The relationships between those abstract ideas, so how they're connected to each other. This thing has an instance of this other kind of thing. And the behaviors, so the verbs. How do these things modify themselves? How do they modify other things? How do they interact with each other in the form of methods? We were specifying methods in the class diagrams that we were coming up with because we wanted to model how these things make changes to themselves. Data modeling is taking a system and trying to build up some abstraction of that system. I want to come up with the idea of the nouns that are in this system. So what are the big abstract ideas in this system? I want to come up with the properties. So like, what do each of these things has of? What are the properties of each of these different nouns that I've got? And how are those relationships, how are those different classes or things related to each other? So what kinds of relationships do we have between the different kinds of things that we have in our system? That sounds real similar. That sounds extraordinarily similar between these two concepts. And they're not quite the same picture, Pam. They're not quite the same picture. They're sort of the same idea. They are very much related to each other. I'll come to you in just a second. They are very much related to each other, but there are some differences between these two concepts. One is that our domain model includes behaviors. When I'm thinking about data modeling, I do not include behaviors. I'm not caring about how this thing is going to change itself. I just want to know what the thing is and how it's related to other things. In data modeling, we're talking about data. And a data point is inert. It doesn't do anything. It exists, but it doesn't change itself. It doesn't change other things. It exists, and it has properties, but it doesn't do anything. The other thing is that our target is quite different when we're thinking about this. I'm going to say, at least for us, domain modeling, the target is, I want to build this class diagram that really represents the classes I'm going to write in my code. In data modeling, what I'm going to say is, I'm not trying to make classes that are going to exist in my code, but rather I'm trying to build up these tables in my relational database, where the tables are going to have inert data. It's data that exists, but it doesn't do anything. It's just there, and I can ask questions about it, but it doesn't do anything. It doesn't do anything. Yeah?
Okay, so can it be viewed as the data modeling thing containing domain modeling as a subset of it? Or in Venn diagram, those are kind of things that intersect but are not the same. Like, it is not that one contains the other.
I'm skipping ahead here. This is kind of the relationship that we've got. So I'm going to say that data modeling is kind of a subset of domain modeling. Yes. I realize now that I'm looking at this, and the only thing we know is class diagram here, and the words ER diagram have not been uttered, but I'm looking for the subset symbol. That's what I'm looking for here, or superset symbol. We can assume that domain modeling is a superset of data modeling. That might be a definition that other people will argue about, but I think that's a fair way to think about what we're doing here.
Like it is domain modeling that doesn't have behavior, something.
Domain modeling has behaviors. Please just ignore all of this stuff. Yeah, domain modeling has behaviors and data modeling does not have behaviors. Yeah. Okay. A table, let me take a step back here. We all know how to write classes. Yeah, yes. Thumbs up. Everyone, please. Yes, thumbs up. Everybody knows how to write a class in this room. Yeah, everyone knows how to write a class. So like going from this class diagram to public class whatever or class whatever, or gosh, now we're starting to write export default class whatever. We all know how to write a class. I've got this class diagram. I can take that and I can turn it into code. The tables that I'm thinking about are more like this. So this is a screenshot of that really powerful tool that we talked about last term in the context of testing. This is a screenshot of a spreadsheet. This is the kind of tabular format that I'm thinking of here. Tables consist of two major things. They consist of columns. Columns are labeled. They have names, or in this case, they are labeled with the alphabet. And we have rows. The rows here are going to be typically vertical. Horizontal, sorry, and our columns are going to be vertical. Columns have labels. Rows in a database don't usually have labels. They don't have sequence numbers in the same way that a spreadsheet does. There are just rows in a database that we're able to ask questions about. The purpose here is we're trying to take the data that we've got and represent it in this two-dimensional structure. The two-dimensional structure consists of rows, examples of the data that we've got, and columns, the named properties of this thing that we're thinking about. And so the question here ultimately is, how do I go from classes, these things that don't really have a shape, like I'm trying to imagine what the shape of a class is in my head, and I can't really think of the shape of a class other than like the indenting that I use when I'm starting to build up this class structure. I can start to think about this in the context of JSON, but again, it's really just like indenting stuff as opposed to having any other kind of structure here. How do I take the shape of this class and turn it into the shape of a two-dimensional thing that represents instances of these classes? What we're going to do in this course is take the class diagrams that we have been building up in the last 2 courses, and I want to add extra information to those class diagrams. I want to make changes to the class diagrams that make kind of help us make decisions about how we're going to represent these tables and the relational database that we're going to be working with. The first thing that we're going to add here is this idea of cardinality. Cardinality is about describing the relationship beyond just composite and aggregate. It's about telling how many of each thing on either side of this relationship there are going to be. So what I mean by that is we can have a one-to-one relationship. I have 2 classes, and this class A has one instance, exactly one instance of this other class B. B has exactly one instance of this other class A. This is like a single property or a single instance variable in each of those classes that are referring to each other. We can have one-to-many relationships between our classes, where one-to-many is, I have a class A, it has a collection in it, an array of class B. There are one of these and many of these in the relationship that we've got. For each one of the things that's in this collection, there's one of the owning instances of this thing. So this is like a collection or an array relationship that we have right now in our classes. There can also be many-to-many relationships. Many-to-many relationships is something that is not likely to happen in the kinds of classes that we're working with, but this is more like I can have a collection on this side and a collection on this side, and they might overlap with each other. So both of these classes can have collections of each other, and there are going to be the kind of relationships that are that way. So this is like a bidirectional collection or array relationship. Yeah?
Do we need to think about these relationships, whether or not they imply opposite or aggregates, or is that not really related?
They are related to this idea of composite and aggregate, yes. But it's going to be more of the form of we have these composite and aggregate relationships. What is the cause of that composite and aggregate relationship? So the one-to-one here is I have an instance variable and an instance variable, or I have an instance variable here, and that's it. That can be composite or aggregate, but the relationship is just, it's a single instance as opposed to an array of things. If I have an array of things, now I'm starting to think it can be composite or aggregate, but it's going to start to tell me about how many of each of those things are. So composite and aggregate don't inform which one of these we're going to be choosing, but composite and aggregate are telling us that we have to choose one of these things to represent that idea. Yeah.
So in one-to-one, is it kind of also bidirectional, because like you have class A having an instance of class B, but then you also have to have class B having an instance of A?
Not necessarily. So this can be, we have class A that has an instance variable of type B, but B doesn't know anything about A, at least in terms of the structure that we've got right now.
Okay. Like with one-to-one and one-to-many, can it be like the same 2 classes A and B have that from A to B we have one-to-one, like A holds one instance of B, but like B holds multiple instances of A, if that could happen.
So that's going to be one-to-many still. That would be one instance owns this thing. This instance can own many of these things. We're going to mark up an example of this to make it clear what we're doing, so we're not just hand-waving around these ideas. I do want us to take the class diagrams that we've got, and I want us to start adding back references. So while it is possible, to your question, to have a class A that has an instance of B in it, but B doesn't know anything about A, I want to make that relationship happen. I want to force that to be part of our class diagram here. If I want that to be the case, if I want to have that relationship, I want it to be bidirectional between the 2 instances of these classes. We're also going to add some special constraints on the values that we have in our classes. And the special constraints that we have on the values are going to be about all instances of this object. The all instances of this object are going to be things like, it's okay for this to be null or undefined. So this property, as it is right now, is allowable to be null. I may not have a relationship with something, so it's okay for this thing to be null. If a value must be unique across all instances of this thing. If I have a property on this class that is used to uniquely identify this single concept or this single idea, I need to say that this is the property that is going to uniquely identify this specific instance across all other instances of the same class that we have in our system. This is going to be similar. So what we're doing is very similar to this idea of an ER diagram, an entity relation diagram. This is something that you will learn in Comp 3380, assuming that is not part of the email that you got. I don't think that would have been part of the email that you got. It is. This is something that you'll learn in a third-year databases course, whatever course number that has when you take it. ER diagrams are something that will represent data modeling. But when we think about this from a purely database perspective, we're thinking about this from a purely database perspective and not at all in relation to classes of things and the way that we are thinking about it. This is very similar to the idea of ER diagrams, but we are emphatically not drawing ER diagrams. I do not want to draw ER diagrams in this class. Why not, though? That's a fair question to ask. Because it would be kind of redundant for us to draw that. If I have this class diagram that already exists, that encodes a lot of the information that I've got in what an ER diagram would have, I can say that the annotated class diagram, adding that extra information that we just talked about, that's kind of like a superset of what a data model or ER diagram would have anyway. It's got all that stuff plus a little bit more. The behavior that we have in the system. Sort of. I'm going to say sort of here. Again, this is not a mathematically correct interpretation of this, but for us, this is good enough. I don't want to have two diagrams because having two diagrams would just have two things that have the same information embedded within them. If I were to ask you to do ER diagrams, I would be asking you to learn a whole new thing for this course. And I don't really want to do that. I'm asking you to do enough as it is with TypeScript and HTML, but not CSS, and learning to do things with GUIs, and starting pretty soon to do things with SQL. There's enough going on in this course that we don't need to learn another kind of class diagram or syntax to represent another kind of diagram. If I made you do ER diagrams on top of class diagrams, you would have to have two diagrams that you're just keeping in sync with each other, and that would be painful. That would also mean that I am going to have to look at two different diagrams every time I want to do assessments. And I don't want to do that. I don't want to have to check to see that you got this in sync. I don't care. I want to have everything kind of embedded within one single diagram. This is not ER diagrams. And so to that end, we are going to have to agree on some conventions for this course. This is not a formal definition of anything that's in an ER diagram. This is stuff we are just making things up here for the purposes of this course to be able to express the things that we want to be able to express with these diagrams. The conventions that we're going to use are cardinality is going to be represented by the number 1 to represent there's 1 on one side of this, the symbol plus or the symbol star. 1 means there's exactly one of these things. Plus means there's one or more of these things. So there must be one, but there can be more than one. And star means 0 or more. 1 means the array that we're got in this thing has to have one element. Star means the array can be empty. That's ultimately what we're trying to say here. If a value can be null or undef, then in the class diagram that we're building up, I'm going to say use question mark as part of the type. Similar to the syntax in TypeScript, I'm adopting the syntax to say, let's say question mark is going to say this can be null. It's possible for this thing to be null in the data that we're thinking about. And if the value must be unique for all instances of that class, I want you to use this tilde to represent that it is a unique value. There can be one value of this in this class of this value, and that's it. Every other class instance must have a different value for this thing. I want to add bidirectional relationships. I want to make changes to our class diagram so that if we have a trainer that has Pokemon, I want Pokemon to have a trainer back. I want to have these relationships be bidirectional explicitly for all of the classes that we've got. So I want to take these ideas and I want to start marking up this example that we have here so that we can start to see an idea visually of what we're trying to think about with all of this. So I'm going to pop over here. I will share this with you after class so you don't have to feverishly copy all of this down if you don't want to. But what I want to start doing with this is the domain model that we have so far. We have a trainer class. It has a collection of Pokemon that it's calling team. Our Pokemon is minimal. It has an HP, a hit points value. It's a number. There's nothing else in our classes right now. This is the core structure of what we've got. The very first thing that I want to do is I want to add some properties to these classes. They are minimal, but they're not useful. Oh my gosh. Pokemon with an HP and nothing else is not a useful class. It's not a very good class to have. I think a good representation of a Pokemon is that it should have a nickname. It should have some kind of a name so that we can refer to that Pokemon by its name when we're looking at it in lists of things. So the very first thing that I want to add here is I want to add this Pokemon has a nickname. This Pokemon has a nickname, and I'm going to assert to you that this nickname must be unique across all instances of Pokemon. If I make another instance of Pokemon, if I make an instance of Pokemon and I give it the nickname Bulby, B-U-L-B-Y, I want to assert that every other instance of Pokemon must have a different nickname from that. No other can have the same nickname. The thing that I want to use to distinguish that is I want to use this tilde symbol. I'm going to put that here. When you're drawing this with mermaids, I'm going to expect it to be looking like this. But for us, for this diagram, I'm just going to put it on top of what we got.
At this point, we're kind of switching from the minimum viable product design of this domain model to
something a little more functional and usable, yeah. Out of necessity, because our minimal classes here don't have enough information for us to do the kinds of things that I want to do with this class diagram right now.
But we're still keeping it minimal.
I'm keeping it as minimal as necessary. So I'm not putting type on Pokemon. I'm not going to do like max HP. I'm not going to do any of that stuff. I'm adding stuff out of necessity for the example that we're working on. Yeah. I'm going to add a little note here to say that nicknames are unique. Every instance of Pokemon I make must have a distinct nickname. I cannot share nicknames across Pokemon. It must be uniquely identifiable across all instances of Pokemon. That's my goal here. I have a class trainer and I have a class Pokemon. I want my relationships to be bidirectional. And when I say bidirectional, what I mean is I want an instance of Pokemon to know what its trainer is, and I want trainers to know what their Pokemon are. So I'm going to add to that a trainer property. The trainer property itself, it can't be null for a Pokemon. if I have an instance of a Pokemon, at least in this setup that I've got right now, it must have a trainer. I'm going to assert that instances of Pokemon must have trainers attached to them. The trainer also is not unique for all instances of Pokemon. I want a trainer to have many Pokemon. And that means that there will be many instances of Pokemon that have the same trainer class instance attached to them. My relationships are bidirectional here. I now have trainer has Pokemon and Pokemon has trainer. I want to add to my diagram a diamond on the other side of this line. And I'm going to add a note here that says that Pokemon are aggregated of trainer. Trainers are composed of Pokemon. So our ownership model here is that an instance of trainer has ownership of all of the Pokemon that are in that array. An instance of Pokemon has a trainer, but it doesn't own the instance of trainer that it's got. I want to be able to delete a Pokemon, and that shouldn't cause my trainer to be deleted. I want to be able to delete a trainer, and all of those Pokemon should be deleted. That's the relationship that I want to have between these things.
Even if the Pokemon holds only one instance of trainer, between those two we have many to one, or one to many, sorry.
So that's our next step here, is I want to mark this up. The orientation of these diamonds is the same way that I want to have the orientation of the 1, the plus, or the asterisk, the cardinality that I want here. So what I want to add to this is that a Pokemon has, I'm going to change the color here, sorry. I'm using blue for notes. Oh my God, there's a giant crack on my screen. It still works, oh no. Okay. When I look from Pokemon toward trainer, there's no crack on that screen. It's definitely, okay. When I look at Pokemon, I'm gesturing at what's on my screen here. When I'm looking at Pokemon toward trainer here, I'm saying that that relationship is aggregate and there's exactly one of them. So when I'm looking from here to over there, I see that I am aggregated of that thing and there's exactly one of them on that other side of this relationship. Looking from trainer to Pokemon, I'm going to say that, and we can have pedantic arguments about technicalities in the Pokemon game. We can say that a trainer can have 0 Pokemon attached to it. But if it does have Pokemon attached to it, it is composed of those Pokemon. So now what we're starting to say here is, in addition to this has an array of Pokemon, we're allowing that array of Pokemon to be empty. This is a little different than what we were doing with invariance and saying that at least with Java, that must not be null. It's a little bit different than invariance. We're saying it's explicitly allowed that this can have 0 things in it. I'm going to add now something similar to my trainer class. I'll come to you in just a second. I'm going to add something to my trainer class here. I want my trainer to also have a nickname. And what I want to say about this is that across all instances of trainer, this must be unique. No 2 trainers can have the same name. Every time I make a new instance of this, I don't want it to have the same name as other things.
So I was just going to ask, that's what that tilde means across all instances.
Yeah. And just to make sure that we are all on the same page here, I have included that here. Yeah.
Like in a Pokemon and trainer shares.
All instances of that same class. So across all instances of Pokemon, only one can be called Bulby. A trainer can also be called Bulby, though. But then if there is a trainer that's called Bulby, no other trainer can be called Bulby. Yeah.
So like, this specific for the database, or should we reflect this on our implementation?
This is specifically for the database. I don't want you to enforce this in your code. This is really explicitly for the database itself. Yeah.
Might jump down a little bit here, but is there a reason that we're using this custom notation instead of describing this as a design by contract kind of thing?
This is not about design by contract anymore. This is now describing the data for the purpose of putting it into a database. The things that we're deciding here, or that I'm deciding on your behalf about this, are going to basically tell us how we're going to structure the database that we create when we get to the point of creating the database.
Sure.
Yeah, yeah, yeah.
No two Pokemon can share the same nickname. You mean like no two Pokemon, the same trainer can share the same nickname, or like another trainer can have the same like a Pokemon?
In this case, I mean no two Pokemon instances at all can share the same nickname. The relationship that you're describing, which is a reasonable one to want to say, you can only have one Pokemon that has this nickname on your team, but other people can have the same nickname. That's a harder relationship to express. For us, we're just going to say all instances have to have unique nicknames. Yeah. The last thing that I want to do here is I want to add a new kind of relationship. And the relationship that I want to have is, I'm going to add a new type to this setup. I'm going to add a new idea that's called Pokemart. These are places that you can go to in the different towns and cities in the game to buy items. This is where I can purchase stuff from a shop. So I can get Pokeballs or potions or antidotes or burn heal or whatever kinds of products I want to be able to buy. Or you can buy a bicycle for an absurd amount of money until you realize you can get it for free from somewhere. No, you get a voucher for the bicycle. Is that how it goes? I forget. It doesn't matter. You can buy a bicycle. You can buy all sorts of stuff at the Pokemart. Thing that I'm going to say about the Pokemart here is that the Pokemarts are going to have a name, and they are also going to be unique across all instances of Pokemarts. No two Pokemarts can have the same name in this entire system. What I want my trainer to have is I want them to have a reference to Pokemart, and I want them to have a favorite Pokemart that they go to. But I don't want them to have a favorite Pokemart that they go to. And so I'm going to mark this up here with question mark. This is allowed to be null. When you are writing this in Mermaid and your class diagram, I would expect this to look like this. With the type. So my comment here I want to have a favorite, but I don't have to have a favorite. I'm allowing this to be null. It's okay if this value is null. That means that I'm going to have a relationship between these two classes. My trainer has a Pokemart, maybe. The relationship that the trainer has with Pokemart is aggregate. If I delete the trainer, I don't want to delete the Pokemart. The Pokemart should stick around. And the relationship that I have going backwards, so I want to have this bidirectional relationship, is that I'm going to have an array of trainers. And I'm going to write favorited, I guess. So these are the collection of trainers that have favorited this specific mart. The collection of trainers is also aggregate. This shop goes out of business. I don't want to delete all the corresponding trainers. They are aggregated of each other. Here, I'm also going to mark this up with a numeric representation of the system that we've got. When I look from trainer to Pokemart, I've got exactly one of those, but nobody's required to have a favorite, and so I've got asterisk, 0 or more on this other side. So the things that we're adding to this diagram now, we're marking things like optional effectively. I'm going to say that this is allowed to be null. I'm not required to fill this value. It's okay for this to be null. I'm saying here, across all instances of this class trainer, there can be only one value of a certain value. Only one trainer can have this nickname. All others must be different. The relationships that I have between these different classes is that trainers have Pokemon. They are composed of it, which is what we've seen before, but now we're saying they can be 0 or more of these Pokemon on the other side. A Pokemon has a trainer. It is composed of trainer, aggregated of trainer, and it has to have exactly one trainer. You can't have no trainer that's attached to a Pokemon. Yeah.
Then from trainer to Pokemon, shouldn't we have something different than one? Because like the favorite that we have could be there and could also not be.
I'm going to say that it is. I'm going to say that it's one, just because there can only be one if it is going to be one.
Okay, so like the one that we're writing there stands for at most one.
The one that I'm writing here, you're right. The one that I'm writing here is really meaning to say 0 or 1. Those are both valid values for this to be. Yeah. Yeah.
Are there going to be any times where we might have to like differentiate between we want exactly one or we want between 0 and 1? Or is that kind of?
Well, the case here, I think, is where we might say it can be 0 or 1. But for us, I'm gonna amend our convention to say that the 1 here means 0 or 1. That's the amendment that I'm going to make. Yeah. Okay. I will share this diagram with you after class. I'm going to go back to our slides here. And so a good question here is, how do I take this class diagram and actually go to this tabular format? I've got this spreadsheet, but how do I get from this marked up class diagram that has now tildes and question marks and numbers and stars on it? How do I go from that to an actual table? And here is where we're going to start thinking about this new programming language that's called SQL. SQL is a language that we will use to describe data. The language itself lets us describe data, and it lets us ask questions about data. It lets us describe data, it lets us add data, it lets us ask questions about data. But it is otherwise inert. These are not class instances. They don't do anything. They just live in a database. We're going to use some SQL commands to specify information about the tables that we want to create and the columns of the table that are in the database. The names that we're going to use for things are going to be the class names. So in my class diagram, I have these 3 different concepts. I have a trainer, I have Pokemon, and I have Pokemart. These are going to be the names of the tables. If I were to imagine this as spreadsheet software, this is tabs. These are going to be different sheets, and the sheets that I'm going to have are named Trainer, Pokemart, and Pokemon. These are the three things that I'm going to have in this. Each of those tables will have columns in them, and the names that we're going to give to the columns are the properties that are on the classes. So my Pokemon is going to have a nickname and HP. My Pokemart is going to have a name. My trainer is going to have a name. We're going to have to model these relationships somehow. We'll think about that when we get there. The types that I'm going to give for the columns in my database are effectively the same as the attribute types that I've got. We've got string and number in TypeScript. I'm going to use things that represent the concepts of strings and numbers in SQL. I've linked here to, this is a Wikipedia entry that describes the list of data types that are available in SQL. We'll demonstrate the ones that we need to use for this class in class. We're also going to take those question marks, those tildes, and the relationships that we've got between different classes and start to encode those in the structure of the table that we're going to build up. In this case, there's no real way to think about that as tabular format. This is going to be constraints that we have on the table itself. This is going to be things like, I want to make sure that there's only one instance of Pokemon that gets inserted here that has this specific nickname. The format of create table looks a little bit like this, but I think this is best demonstrated in some code. So I'm going to open up this link here. I think I put a link to this in the course content section for today's lecture. And in the last couple minutes of class here, what I want to do is start writing some code that is going to go through the process of building up this table format for us. When I'm deciding how to create the tables, I'm going to need to create them such that I am able to make references to the other tables that I'm making. I'm going to go back to my diagram here. We're going to have exactly 3 tables that we're going to make. One for Pokemon, one for Pokemart, and one for Trainer. I'm going to start with Pokemart. The syntax that we're going to use here is that we're going to start with the keywords create table. Create table is the first command that we're going to work with. This will create a table. This is like me opening up Excel or LibreOffice Calc and clicking on, well, I don't click on anything to get a table to show up, but this is me putting a name on the tab that is the default sheet that shows up. I want to create a table. I'm going to call it Pokemart. And what I want to give inside of Pokemart, what I want the columns to be, I'm going to open some parentheses here, is that I want to have a name, this is my first column. The column is of type name. The type is going to be of varchar. SQL has 2 different string types that we can work with. There are more than this, but for us for now in this course, there are 2 types that we can work with. There's char and there's varchar. Char are fixed length strings. Varchar are variable length strings. Fixed length means that the string will be padded with spaces if you don't use all the characters. Varchar means it will only take as many as is necessary to represent the string that you've got. When we define varchars, we have to specify a length. So I'm going to say that this can be up to 255 characters in length. This is a limit. We're going to ignore that limits exist, and we're just never going to type in more than 255 because that's outside of the scope of this course. This is a limit that we will work with. Yeah.
Just char. Spaces would be bad.
If I type in just char here and leave this as 255, it will take 255 every time. And it will just fill with spaces as much as it needs to. If we omit the number, I'm not sure what the default choice is for these different types. It's not ultimately flexible. There is also a text type that is useful for large volumes of text. Most strings are less than 255 characters. That's more characters than usual, like in terms of naming stuff. Not a lot of things are named more than 255 characters. I think there are maybe Welsh or German towns that are more than 255 characters, but those are extreme examples of stuff. So I've got the name of my table. I've got the name of the column that I want to make. I've got the type that I've got. But what I also want to say about this is that it must be unique. So it has to have a unique value. No two Pokemarts can share the same name. And I'm also going to say, we didn't say this, we said the opposite. What I'm going to say here is that this can't be null. In other words, you must provide a name for this Pokemart. We said the opposite in our diagrams. If I go back here, what we said was that this is allowed to be null. But what I'm saying by default now is that this has to be a not null value. This is the only thing that I actually want to have in this Pokemart. Okay, this is the only thing I want to have in this Pokemart. The other property that my Pokemart has is it's got a list of trainers. When we're specifying columns, I can't say this column has n possible values. And so I really can't model that in a table like this. Instead, what I'm going to have to do, and this was the purpose of us adding this bidirectional relationship. I've got this array, but I want to put this Pokemart here because what I really need to be able to do here is I want to model in my trainer table which is the favorited Pokemart itself. So where we can have arrays and collections in our classes, we can't really have an array or collection in a table. I can't have a flexible number of columns that are attached to a table to represent that idea. So I'm inverting this relationship. I'm going to use that single instance property, and I'm going to use that as what I'm going to say for the relationship here. I'm going to add one more table, and then we'll wrap up for today, and we'll keep working on this on Tuesday next week. I want to make the other trainer table. I want to make the trainer table. So create table. I want to make this trainer table. The trainer has a nickname. The type of this is string in our TypeScript. So I'm going to use varchar. I'm just going to default 255 every time. I welcome you to default 255 every time. This is a sane choice to make for lengths with variable length strings. We've said that this must be unique, and we also did not say that it could be null. So I'm going to assert that this cannot possibly be null. The other thing I'm going to say is that this trainer has Pokemon, but just like Pokemart has trainers, I can't actually do that with this table structure that I've got. But this trainer has one favorite Pokemart, and I can do that with the table structure that I've got. So I'm going to say here, favorite mart. This has to be the same type as what we had with our favorite mart, with our Pokemart, the name of the Pokemart. Actually going to name this favorite mart name explicitly. Whoops. This can be null. It's allowed to be null. And many trainers can have the same favorite mart. So I don't need to put any constraints on this here. The place that I do want to add a constraint to this is I want to add a new idea. I want to enforce that there is an actual connection between the tables in this database. want to add this new idea of this thing that's called a foreign key. This is me saying, I want to be able to refer to a property that's on a different table. I want to actually have this connection appearing between these two different things. The foreign key that's in my table is going to be favorite mart name. And this references, so this is going to be referring to another table. The reference that we're making here is that this references Pokemart. And the thing that we're referring to on Pokemart is its name. The summary of this is that when I insert values into this favorite mart name, they must exist in that other table. They have to exist in that other table for it to accept that. I'm going to hit enter here. We will come back to this. We will start at the beginning. This is a taste of SQL for now. But at this point, what you should be able to do at the end of today's class is you should be able to model these relationships and some constraints between the different types that we've got. And beginning, you should begin to be able to. You should remember the words create table, not null, unique. You should be able to remember the word foreign key, and we'll start doing this more in class next week. Thanks all for the extra couple minutes of your time.